Dear all, grand welcomes to another sessions of Woutons Edu's Online. In this session, we are going to discuss the basic concept of coordinate geometry. We are starting with straight lines. First, we discussed about popular representation of coordinate system. That is rectangular coordinate system or Cartesian coordinate system. And we will discuss about polar coordinate system. Then we will do some problems. Followed by, we will discuss distance formula. We have to do some application of distance formula. First application is finding circumcenter of a triangle. Then by making use of distance formula, we will do the interpretation of various geometrical figures like triangles, quadrilaterals, etc. Then we will use this distance formula to identify what type of triangle is, whether it is a right angle triangle, or a scalene triangle, or equilateral triangle, obtuse angle triangle, acute angle triangle, etc. We will identify by making use of distance formula. Then we want to identify what type of quadrilateral is, whether it is a square or a rectangle, or a parallelogram or a rhombus, or a kite or a trapezium. So again, a grand welcome to Woutons Edu. Cartesian coordinate system or rectangular coordinate system in any two-dimensional space. So in this system, we have an xy plane. This is our xy plane. This will represent x-axis and y-axis. Okay, so any point xy in a two-dimensional space can be represented a single point in this plane. For example, this is a point x comma y. This is a point x comma y. Then what is x and what is y? So x is nothing. That is a perpendicular distance measured from y-axis. This is our y-axis. So this distance, that is a perpendicular distance measured from y-axis, is x. And this distance, that is a perpendicular distance measured from x-axis, is nothing but the value of y. This is our y. Now, for example, I want to mark a number 5, 4. So, this is 1 unit, 2 unit, 3 unit, 4 unit and 5 unit. This is 0, 1, 2, 3, 4. So, the point 5, 4 can be represented in this plane by, this is from 5 unit. Okay, and from 4 unit. So this is a point 5, 4. This distance is 5 and this distance is 4. So what is the coordinate at this point? This point is represented by 5, 0. The value of y coordinate is 0. Similarly, this point is represented by the 0, 1, 2, 3, 4. That is, x coordinate is 0 on y-axis and y coordinate is 4. So this point is 0, 4 and this point is 5, 0. And this is our required point 5, 4. This is a representation of a point in xy coordinate. Suppose I have minus 3 and minus 4. This is lying in the third quadrant. So minus 3 is minus 1, minus 2, minus 3. And minus 4 is minus 1, minus 2, minus 3, minus 4. So from x-axis, we are drawing a perpendicular distance and y-axis also drawing perpendicular distance. This will represent the x-coordinate. That is a perpendicular distance from y-axis. And this is a perpendicular distance from x-axis that will represent the y-coordinate. So this is the point minus 3, minus 4. Okay, this is a way in which point is representing in xy plane or in Cartesian coordinate system. Now let us see what is polar coordinate system. So in polar coordinate system, any point in a two-dimensional space can be represented by r, theta. Okay, this is a point P that is represented by r, theta. Now, I am drawing a two-dimensional plane. Let this be our xy plane. Now, a point, this is a point this point is represented by r comma theta, where r is the distance measured from origin. Origin is 0, 0. So this distance is r, and the angle measured from x-axis in the anti-clockwise direction is theta. So this angle is theta. Okay. If you are measuring the angle in clockwise direction, that becomes minus theta. Now what is the relation between polar coordinate and Cartesian coordinate? In Cartesian coordinate, this is represented by x, and this distance is represented by y. Now what is the value of cos theta? We can write cos theta is equal to x divided by r. X by r. So x is equal to r cos theta. And what is sin theta? Sin theta is equal to y by r. Sin theta is equal to y by r. This implies y is equal to r sin theta. Okay. So r is equal to, this is point in xy coordinate, x is equal to r cos theta and y is equal to r sin theta. So this is the conversion between Cartesian coordinate system and polar coordinate system. So what is the value of r? By using Pythagoras theorem, r square is equal to x square plus y square, or r is equal to root of x square plus y square. Find the polar coordinate of 3 root 3. 3 root 3 is given in rectangular coordinate system. So we have x is equal to 3 and y is equal to root 3. In polar coordinate system, r is equal to root of x square plus y square, that is equal to square root of 3 square, that is 9, plus root 3 square, that is equal to 3, that is equal to root 12 is equal to, you can write 12 as 4 into 3. So this is equal to 2 root 3. Now what is theta? Theta is equal to tan theta is equal to y by x. This implies theta is equal to tan inverse y by x. That is equal to tan inverse y is root 3 divided by 3. That is equal to tan inverse 1 by root 3. That is equal to 30 degree. So the point in polar coordinate is represented by r comma theta. That is equal to r is 2 root 3. Theta is 30 degree. 30 degree is pi by 6 radian. So this point can be represented in xy plane as a straight line having a length 2 root 3. This is r. And this angle is 30 degree or pi by 6 radian. This is our point P. Okay. Now find the Cartesian coordinates of 2 comma pi by 2. So this is a polar coordinate is given. Here r is equal to 2 and theta is equal to pi by 2 radian. So x is equal to r cos theta, that is equal to r 2 cos pi by 2, that is equal to 2 into 0 is equal to 0. Okay. And y is equal to r sin theta. Y is equal to r sin theta, that is equal to 2 sin pi by 2 is equal to 2 into sin pi by 2 is equal to 1, that is equal to 2. So in Cartesian coordinate system, x comma y is equal to 0 comma 2. So the point in xy plane, this is our x-axis and y-axis. X coordinate is equal to 0 and y coordinate is equal to 2. So this is a point 0, 2. This is 0, 1, 2. So this point represents 2 pi by 2. Okay. Now let us discuss about distance formula. Suppose we have 2-dimensional space. We want to find the distance between 2 points in xy plane can be obtained by making use of distance formula. Suppose I am drawing an xy plane. This is x axis and y axis, a two-dimensional plane. Now, let I have a point A. This point is denoted by x1 comma y1, and I have another point B. Let this point is denoted by x2 comma y2. Now I want to find the distance AB. This can be obtained by making use of this formula. So what is the length of AB or magnitude of AB is equal to question. Okay, now I am drawing a perpendicular distance to x-axis from A and also from B. And also I am drawing a perpendicular distance from B to y-axis, also from A to y-axis. So this is the distance along x-axis. This is represented by x1. This distance is x1. And this distance is x2. Now this distance is y1. And this distance is equal to y2. Okay, now what is this distance? This distance that is equal to x2 minus x1. This will represent x2 minus x1. And this distance is equal to y2 minus y1. That is y2 minus y1. Now let this point be some C. This point. Now use Pythagoras theorem. That means AB square is equal to AC square plus CB square. That is AC square plus this distance, this vertical distance, that is CB square. So this is equal to AC square. AC is x2 minus x1. So x2 minus x1 the square plus this distance is y2 minus y1, that is plus y2 minus y1 the square, that is equal to AB square. Now AB is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This is our distance formula. Okay. So distance between any 2 points is equal to square root of the square of x difference plus the square of y difference. Okay. So this is a proof for distance formula. So making use of distance formula, we can do some problems. First problem is finding the circumcenter of a triangle. Okay. Circumcenter is a perpendicular bisectors of the sides of a triangle meet at a point. That point is circumcenter. Now consider a right angle triangle. Now I am drawing a perpendicular bisector to this side, hypotenuse. Let this be A, B, C. Okay, so a perpendicular bisector to this side is drawn, and for this side is drawn, for this side is drawn. So this will meet at a point. This angle is 90 degree, this is 90 degree, and this angle is also 90 degree. This will meet at a point. That point is circumcenter. So this is marked by, circumcenter is marked by O. Okay, this is a, so for a right angle triangle, circumcenter is always lies on the hypotenuse of the triangle. Now consider an equilateral triangle. Now for this triangle, I am drawing the perpendicular bisectors. So perpendicular bisectors to the sides of the triangle. This is 90 degree, 90 degree, 90 degree. This point is O, that is the circumcenter. This lies inside in the case of an equilateral triangle. So by making use of distance formula, we can find the circumcenter of a triangle if the coordinates of vertex is given. Suppose we know A, coordinates A, B and C. Then by using the distance formula, we can find the circumcenter of this triangle. Now, the question is vertices of a triangle are given. The points are A minus 1, 5, B 5 minus 1 and C 6, 6. Find the circumcenter of this triangle. Now I am drawing a triangle. Let this be a triangle. Let this is represent A minus 1 5. This vertex be B 5 comma minus 1, and this vertex be C 6 comma 6. Now this is our circle. Okay, so I am drawing the circumcircle. Okay, circumcircle. Now let OXY be the coordinate of circumcenter. Circumcenter O. This is represented by the coordinate x comma y. Now this is a radius. This is also radius. This is also radius. These all are radius. So this point OA is equal to OB is equal to OC. Okay, that is OA is equal to OB is equal to OC, that is equal to circumradius R. Okay, now by making use of distance formula we can find length OA. So OA is equal to OB. Now OA is this distance. This distance is obtained by using distance formula, that is x difference. X is x minus of minus 1, that is x plus 1 the whole square plus y difference, that is y minus 5. Y minus 5 the whole square, that is equal to OB. OB is square root of this distance, that is x difference, that is x minus y the whole square plus y plus 1 the whole square. Now simplify this expression. This we will get, and x square plus 2x plus 1 plus y square minus 10y plus 25, that is equal to x square minus 10x plus 25 plus y square plus 2y plus 1, and squaring. So this squaring the both sides of equation. So this becomes square root. So this becomes, the equation becomes like this. Now x square and x square get cancelled. Y square and y square get cancelled. 2x and minus 10x. So that become 12x and minus 10y and plus 2y. That is equal to minus, this is taking the LHS, minus 12y. Here it is 1 plus 25, that is 26. Here 25 and 1, 26. That is equal to get cancelled. So this is equal to 0. This implies x is equal to y from this equation. Okay. Now we can equate OA is equal to OC. That means OA is equal to OC. OA is, so OA square is equal to OC square. OA is this term, that is x square plus 2s plus 1 plus y square minus 10y plus 25. This is equal to OC. OC is this distance, that is x minus 6 the whole square plus y minus 6 the whole square. By expanding this term, this becomes x square minus 12x plus 36 plus y square minus 12y plus 36. X square and x square get cancelled. Y square and y square get cancelled. Here it is 2x and minus 12x. So taking into LHS, this becomes 14x. Here is minus 10y and minus 12y. So plus 2y, that is equal to 36 plus 36, 72 minus 26. That become 46. Okay. Now x is equal to y, that is 14x plus 2 into x, that is equal to 46. Or 16x is equal to 46. X is equal to 46 divided by 16 is equal to 23 divided by 8. So our coordinate of circumcenter is x comma y. x is equal to 23 by 8 and y also 23 by 8, comma 23 by 8. So this is the coordinate of circumcenter. Now consider the question. We have point A 3, 4 and B is a variable point lies on the line mod x is equal to 6. Okay, now let's just draw the given condition. Now we have a point A, that is 3, 4. So 1, 2, 3, 1, 2, 3, 4. So this is our point A, that is 3, 4. And we have another point B such that the modulus of AB is less than or equal to 4. And the point B is lying on the line mod x is equal to 6. Mod x is equal to 6 means either x is equal to plus 6 or x is equal to minus 6. So x is equal to 6 means this is 1, 2, 3, 4, 5, 6. So a line drawing perpendicular to x-axis at x is equal to 6. That is equal to, this coordinate is 6, 0. So this is a line x is equal to 6. And x is equal to minus 6. This is minus 1, minus 2, minus 3, minus 4, minus 5 and minus 6. So this is a line x is equal to minus 6. So B is the point lying either on x is equal to 6 or on x is equal to minus 6. Now the condition is that modulus of AB is less than or equal to 4. So distance from y-axis to this is 6. This distance is 6 unit and this distance is 3 unit. So total distance from A to a point on B, that's the shortest distance from A to any point on this line x is equal to minus 3 is 9. So the point B will never lies on this line. So the point B will lies on this line. Let this be point B. So the condition is that the length of this line, that is AB, that is less than or equal to 4. Okay, right. Now let this point B is represented by x, y. So what is the length of AB? AB is equal to square root of x minus 3 the whole square plus y minus the whole square. This is less than or equal to 4. Okay. Now, any point in this line can be represented by 6, y. Since the x is the distance from y-axis. This is always constant for any point in this line. So x can be replaced by 6. So x is equal to 6. So this term become square root of 6 minus 3 the whole square plus y minus 4 the whole square less than or equal to 4. 6 minus 3 means 3 square. Now squaring LHS and RHS, this become 3 square plus y minus 4 the whole square less than or equal to 16. So 9 plus y minus 4 the whole square less than or equal to 16. This 9 can be taken in the RHS. So this become y minus 4 the whole square less than or equal to 7. This implies y minus 4 mod y minus 4 less than or equal to root 7. Or we can write minus root 7 less than or equal to y minus 4 less than or equal to plus root 7. Now 4 is taken to this side. That means become 4 minus root 7 less than or equal to y less than or equal to 4 plus root 7. 4 minus root 7 approximately equal to 1.4 less than or equal to y less than or equal to 4 plus root 7 approximately becomes 6.4. Now we want to find the integral values of b. So the integral values lie between 1.4 and 6.7 are 1.4, then 2, 3, 4, 5, 6. So this is our point 1.4 and this is our point 6.4. So integer values are 2, 3, 4, 5 and 6. So these are the integer values of y. So the point B is equal to, x is always constant. So that is 6, 2 or 6, 3 or 6, 4, 6, 5 or 6, 6. So then these are the integer values of y which will satisfy this condition mod AB less than or equal to 4. In the next lecture, we will discuss about triangles and quadrilaterals. Then how to use this distance formula so as to determine the type of triangle, whether it is an equilateral triangle, scalene triangle, right angle triangle, isosceles triangle, obtuse triangle or acute angle triangle can be determined by making use of distance formula provided the vertices of the triangles are given. Suppose 4 points are given in a two-dimensional space. We can determine whether it is a quadrilateral. Then what is the nature of quadrilateral? Whether it is a rectangle or a square, or rhombus or a parallelogram, a kite or a trapezium. That we will discuss in the next lecture. Okay, thank you. Bye-bye.